Hello, everyone. So this is another paper for the practice, and the paper is May-June 2021, and the variant is 22. Look at the question number 1. The question number 1 is complete table 1.1 by stating whether each of the quantities is a vector or scalar. So this acceleration definitely is a vector. Electric resistance is scalar, and momentum is a vector. Now the next part is state the condition for the object to be in equilibrium. So the first condition is vector sum of all forces acting on the object must be 0. In short, resultant of the all forces must be 0. And the number 2, resultant torque of all forces about a common pivot must be 0. Mean the resultant force 0 and the resultant torque 0. So no acceleration. So it means the object is in the state of the equilibrium. Now the next question is, a floating solid cylinder is attached by the wire to a seabed. The density of the water is 1 into 10 power 3, mean 1000 kg per meter cube. The base of the cylinder is at the depth of 0.190 meter below the surface of the water. The cylinder has a weight of 28 Newton and the cross-sectional area is 0.0230. The wire and the central axis of the cylinder are both vertical. The cylinder is in equilibrium, mean the resultant force is 0. Calculate the to 3 significant figure, the upthrust acting on the cylinder. Look, the upthrust is equal to rho g into volume of the displaced liquid. So rho g a l. Now the rho of the liquid is 1 into 10 power 3. The value of the G is 9.81 and the cross-sectional area is given 0.0230. Look, it's given here. And the height is the length, mean the depth of the liquid is 0.190. So after the calculation, the answer is coming 42.9. So we will write this answer, 42.9 Newton. Next, show that the tension T in the wire is 15 Newton. Look, the weight of the object is acting downward and the thrust acting upward. Then the tension in the string is equal to upthrust minus weight, mean the difference of these two forces is the tension in the string. Look, this upthrust is 42.9 and the weight of the object is given 28. So this is approximately 43 minus 28. So the answer is 15.9 approximately. Next, the wire has the cross-sectional area of 3.2 millimeters square. Calculate the stress. Look, the stress is equal to force divided by area. Now the force is the tension on the wire, and the area of the wire is 3.2 into 10 power minus 6, because we have to divide it by 1000 two times, so it becomes 10 power minus 6. So after the calculation, the answer is coming 4.7 into 10 power 6. Look, this area is given in two significant figure, so we have to write the answer in two significant figure. Now the next part is the surface of the water gradually rises, mean upthrust increases, because the upthrust is rho GAL. This L is the depth of the liquid. So when L increases, upthrust increases. When the upthrust increases, weight is same, then the difference of these two, which is the tension, upthrust minus weight. This weight is constant, upthrust increasing, so the answer of this tension also increasing. Hence, the tension in the string, in the wire increases. So this is question number 1. Now move to this question number 2. A ball is thrown vertically downwards to a ground as shown. The ball is thrown with a speed of u with a height of 1.5. It's not dropped from the 0 speed. It is thrown vertically downward with speed u. The height lost is 1.5. The ball then hits the ground with the speed 8.7. Air resistance negligible. Look, third equation of motion, v square is equal to u square plus 2gs. This final speed is given 8.7 square, initial speed required plus 2, and the g in the equation for downward motion plus 9.81, and the distance covered is 1.5. So 8.7 square minus 2 times 9.81 times 1.5 whole under root is the u, because this is u square. So you have to take the square root, and then after the calculation, the answer is coming 6.8 meter per second. Next part is state how the Newton's third law applies to the collision between the ball and the ground. So look, when ball hits the ground, the force is exerted on the ground by the ball. And due to reaction, the ground exerts force on the ball in the opposite direction. Thus, Newton's third law is applicable. So on hitting the ground, ball exerts force on the ground as action. Then ground reacts, it exerts force on the ball in the opposite direction. Thus, Newton's third law is valid. Okay, move to this one. The ball is in contact with the ground for a time of 0.091 second. The ball rebounds vertically and leaves the ground with a speed of 5.4. Calculate the magnitude of the change of the momentum. So we have to calculate the change of momentum. Momentum is a vector. So final momentum minus initial momentum, velocity. If this direction is taken positive, then this will be taken negative. It hits the ground with positive velocity. I think this is, yes, 8.7. And it leaves the ground with this velocity minus 5.4. So mass of the object is 0.059 the final velocity is minus 5.4 and minus the initial velocity, because this m is taken common. So this is 8.7. So the answer will be minus, which can be ignored for the change of momentum, and it is 0.83 approximately. Next, determine the magnitude of the average resultant force. According to Newton's second law, rate of change of momentum is the unbalanced force, the resultant force. So 0.83 divided by the duration of the contact is given 0.091, 0.091, and the answer for the force will be 9.1 Newton. Next, use the answer to calculate the magnitude of the average force exerted by the ground on the wall during collision. So look, two forces are acting. One is the weight. So the force with which Earth attracting the object, mean the ball downward. And as a reaction, the same force is exerted on the ball. So look, weight is acting down. As a reaction, equal to weight, but due to change of momentum, this force is also active. So as a reaction, weight, reaction of the weight, the force is exerted 0.58. This is the reaction of the weight on the ball, and plus the force exerted due to the change of the momentum of the ball, because when the ball hits and rebounds, the direction of this force is also upward. So this reaction is upward. This change of momentum, rate of change of momentum force, mean the resultant force is also upward. So we have to add both forces. So the answer is approximately, in two significant figure, 9.7. Next, the ball was thrown down with the velocity t, with time t, 0, and hits the ground at t. Sketch the graph to show the variation of the speed of the ball with time t up to t, capital T. Numerical values are not required. Look, initially, it has speed, u initial. Acceleration is constant, which is equal to 9.81, and gradually it increases. So this is the u, and this is the v. So we have calculated u and v. So this is a graph. Numerical values are not required. So just mention this is u and this is v. So this is a graph, and the gradient is constant. Next, in practice, the air resistance is not negligible. Stain will explain, if any, with time t of the gradient of the graph, when air resistance is not negligible. Look, when the air is considered, weight remains same of the falling object, air resistance increases with speed, thus the resultant force, which is the difference of the weight downward and air resistance on the object falling down upward. So this difference decreases because the weight is constant. This is increasing. So this resultant force is decreasing. Hence, acceleration is decreasing. So we have to draw here the graph with the decreasing gradient. Thus, the gradient of the graph decreases because the gradient is acceleration. So the gradient of speed time graph will decrease due to increase in the air resistance. Okay, next question is, a child of the weight 330 Newton is at the point X at the top of the slide. The slide is at the edge of the swimming pool as shown. The child moves from rest to the lowest point of the slide and then vertical distance 4 meters below X. The child continues moving towards the point Y, which is at the end of the slide and the vertical distance of 1.1 above the lowest point. Kinetic energy of the child at 540 is at Y is 540. Calculate the difference in the gravitational potential energy at the point X and Y. So look, difference in gravitational potential energy is equal to mg delta H. Mg is the weight, and the weight of the child is given 330, and the difference of the height is 4.0 minus 1.1, and after the calculation, it is coming 960 joule. This is the loss of the potential energy. Now, the average friction force of the 520 Newton act on the child when they're moving from X to Y by considering the change of the energy, determine the distance moved by the child from X to Y. Now look, how much work is done against friction? So the work done against friction. This 960 potential energy is lost and 540 energy is gained. The rest of the energy is wasted, is converted as heat due to friction. So first of all, we have to calculate the work done against friction. Mean loss of the potential energy is 960. 540 is the gain. It means the remaining energy is utilized against the friction. So this answer is 420 joule approximately. Now, the work is equal to F times D, and the work done is 420, F is required, and the total distance covered is required, and the force of the friction is given. So we will use this, which is 52 times D. Hence, D is equal to 420 energy divided by force. And after the calculation, the distance will be 420 divided by 52. It is 8.1 meter. Now, after the point Y, the child makes a projectile. Question is, child leaves the slide at the Y while the velocity that is at the angle of 41 degree to the horizontal. The path of the child to the air is shown. Mean the projectile. The point Z is the highest point on the path of the child to the air. Assuming that the air resistance negligible, calculate the speed of the child at A. Look, at Y, it has kinetic energy. And kinetic energy at the Y is given. So we can write kinetic energy is equal to 1 by 2 mv square. Look, the kinetic energy is 540. It's given 1 by 2. The mass is weight divided by g. So the weight of the child 330 and the g value 9.81. So 330 divided by 9.81 times v square. Now we can calculate this. So it's 540 times 2 times 9.81 over 330 under root. This is the speed at the Y, and after the calculation, it will be 5.7 meter per second. So this is the speed when it leaves the point Y. Now at Z, it has only horizontal component of the velocity, Vx, and the Vx, the horizontal component, is equal to V cos theta. So the V is 5.7, we have calculated, and its X component cos theta, and theta is given 41 degree. So after the calculation, Let me calculate. Cos 41 times 5.7, it is 4.3. This is the horizontal component of the velocity. Okay, this is question number 4 next. For a progressive wave, mean a wave which has net transfer of energy state, what is meant by the period? It's simple. Time taken by the progressive wave to complete itself, to complete its cycle, to complete its vibration is called the period. State the principle of the superposition. When two waves meet at a point, when two or more waves meet at a point, overlap a point, the displacement of the resultant wave is the algebraic sum of displacements of all individual waves. So this is the principle of superposition. Next, electromagnetic wave of the wavelength 0.040 meter are emitted in the phase from the two sources X and Y and travel in a vacuum. The arrangement of the sources is shown. A detector moves along the path that is parallel to the line XY. Okay. A pattern of the intensity maxima, minima, mean constructive and destructive interference occurs. Distance xz is 1.380 and yz is 1.240. State the name of the region, the electromagnetic spectrum that contains the wave from X and Y. So electromagnetic wavelength is given by remembering the wavelength range. We can determine that this wavelength belongs to, I think, microwaves. So you have to remember are the wavelengths from the chart. Next, calculate the period in picosecond for the wave. Look, speed is equal to distance divided by time, and the distance covered by one wave is lambda, and the time taken is period. And the microwave travel with the speed of light, 3 × 10⁸. Wavelength is given 0.040 and the period. So T is equal to 0.040 divided by 3 × 10⁸. So after the calculation, use the calculator, it is coming 1.33 into 10 power minus 10 approximately. So when we have to convert this into pico, it becomes 133 into 10 power minus 2 multiplied by 10 power minus 2 divided by 1 power minus 2. So this 10 power minus 2 is multiplied with this. So it becomes 133 into 10 power minus 12. And this 10 power minus 12 is already there, the picosecond. So look, this is in two significant figure. There's 3.0 in 10 power 8, two significant figure. So you can write it also in two significant figure, 130. Next, show that the path difference at z between the wave x and y is 3 point lambda. So first, we have to calculate the path difference. The path difference means the distance covered by two waves difference 1.38 and 1.24. So it is 1.380 minus 1.240. This difference is approximately, let me calculate. Okay, after the calculation, this is 0.14, but we have to write this in terms of the lambda. So 0.14 divided by wavelength, which is 0.040. So the answer is coming 3.5, hence proved it is 3.5 lambda. Calculate the phase difference between the wave at the point Z. Look, 1 lambda has phase difference 360 degree. Then 3.5 lambda will have phase difference 360 times 3.5, which is approximately 1260. But we can code it either 1260 degree, but due to this half lambda, 3 plus 1 by 2 lambda, the phase difference is 180 degree because the crest of the one wave is overlapping the trough of the other. So either write 1260 or write 180 degrees. It's up to you. 1260 degree or 180 degree, because when 1 lambda, 2 lambda, 3 lambda, the points are in phase. 1 lambda, 2 lambda, 3 lambda phase difference mean, path difference mean they are in phase. But this is 3.5. So for 3 lambda, the points will remain in phase, but due to the half lambda, they are out of phase, so we can write 180. Now, due to this 180 phase difference, there will be destructive interference and state the intensity of the wave at the point Z. So the intensity will be 0 due to destructive interference. Now the next is the frequencies of the wave from X and Y are both decreased to the same lower value. When frequency decreases, wavelength increases. The waves stay within the same region of the electromagnetic spectrum. Describe the effect of this change on the pattern of the intensity maxima minima, mean constructive and destructive interference. When the wavelength increases, according to the formula, X is equal to lambda d over A in the interference. When this lambda increases, the spacing between the fringes increases. Thus, there will be increase in the distance between maxima and minima. So distance between two consecutive maxima, distance between two consecutive minima will increase, and also the distance between maxima and minima will increase, means the spacing increases. Now the next one, define the ohm. Ohm is the ratio between voltage and ampere in the conductor. It's a ratio between volt and ampere. Instead of the voltage, we will write it is a ratio between volt and ampere, mean 1 ohm is equal to 1 volt per ampere. Or you can write resistance will be 1 ohm if 1 volt potential difference drives 1 ampere current in the wire. But better is we have to write the ratio. It's a ratio between 1 volt and 1 ampere. Next, a wire is made of the metal of resistivity rho. The length L of the wire is gradually increased, assuming that the volume of the wire remains constant. Okay, volume is equal to area into height. When the volume is constant, then the area and the length both are inversely proportional. So L of this wire is gradually increased. When L increases, the area decreases. Show that the resistance of the extended wire is proportional to L square. The formula is R is equal to rho L over A. Now it can be written as rho L, and from this area can be written as volume divided by length. So R is equal to rho L multiplied by length divided by volume. So which is rho over volume L square, rho constant, volume constant according to statement. Hence, the resistance directly proportional to L square, it's shown. Okay, next, the battery of the EMF, capital E, internal resistance, small r, is connected to a variable resistor of the resistor R. An ammeter measures the current I in the circuit. A voltmeter measures the potential difference V across the variable resistor. Resistance R is now varied to change the I and V in the circuit. The variation of the I of V is shown in the figure. So this is voltage against current graph. Use the figure to state EMF. Don't calculate. We have to write the answer. Look, when the current is 0, then the reading shown by the voltmeter is the EMF of the cell. So we have to read this one. This is the EMF. Now, what is the value of this EMF? It is 2.4. So here we have to write 2.4. Next, determine the power dissipated in the variable resistor when there is a current of 5 ampere. Look, current 5. So power is equal to VI or IV. Current is 5 and the voltage for the 5 will be, look, this is 5 current. So we have to read this voltage and this is 1.3. So 1.3 times 5, the answer will be 6.5 watt. And the next, state what is represented by the value of the gradient of the graph. Yes, gradient of V and I graph is resistance, but which resistance? Look, according to Ohm's law, V is equal to IR. But here, the EMF provided is equal to potential lost across the resistor and terminal potential across the external resistor. This is the Kirchhoff's second law. Now, the graph is plotted between I and V. So look, EMF is equal to IR plus this IR is V. So when we will write this equation, the linear form, V is equal to minus IR plus EMF. When we will compare it with a straight line, Y is equal to mx plus c. At the x-axis, the current is plotted. At the y-axis, the voltage plotted. So this minus r is the gradient and the y-intercept is c. Yes, we have read that. So this is not the external resistor, capital R. So this is the negative internal resistance, or just write the internal resistance. So first of all, you have to remember this. When the graph is plotted between V and I, and it's not starting from the mean position, I mean the y-intercept is not 0, then you have to consider this concept. So this is not the external resistance. This is the internal resistance, small r, because V is equal to minus Ri plus EMF. So Y is equal to mx plus c. This x plotted at the x. So definitely this is the gradient. The minus r, the minus small r is definitely the internal resistance. Now move to the next, question number 6. One of the results of the alpha particle scattering experiment is that a very small minority of the alpha particle are scattering to the angle greater than 90 degrees. State what may be inferred about the structure of the atom of this result. So we have to tell about the structure of the atom. Number 1. Central part of the atom is dense, positively charged. And the major portion of the atom is empty. Whole mass of the atom is within the nucleus. So this is the structure. An alpha particle is made up other particles. One of these particles is proton. State and explain whether the proton is fundamental. No, it's not fundamental because the proton is made up of quarks. 2 up, 1 down. Next, a radioactive source produces a beam of the alpha particle in a vacuum. The average current produced by the beam is 6.9 into 10 power minus 9. Calculate the average number of the alpha particle passing a fixed point in the beam and a time of 1 minute, means 60 seconds. Look, electric current is equal to charge divided by time. And the charge is due to the number of the alpha particles. So n times the charge of the alpha divided by t, because the total charge is due to the number of the alpha particles. So the charge of 1 alpha multiplied by number, this is the formula. So we have to calculate this n. So current multiplied by time divided by charge of the alpha, this is the number. Now the current is given, which is 6.9 into 10 power minus 9. And the time is 1 minute, means 60, divided by charge of the alpha. Due to 2 proton, it is double elementary charge, 1.6 into 10 power minus 19. Now let me calculate. It is approximately 1.3 into 10 power 12. So this is the number of the alpha particle due to this current. Now the next is the alpha particle in a vacuum enters the uniform electric field. The alpha particle enters the field with the velocity is the same direction as the field. State and explain whether the magnitude of the acceleration of the alpha particle due to the field decreases, increases, stays constant as alpha particle move through the field. Question is, alpha particles in the vacuum enters the uniform electric field. The alpha particles enter the field with their velocities in the same direction as the field. State and explain whether the magnitude of acceleration of the alpha particle due to the field increases, decreases. Look, nucleus charge is constant. Number of protons remains same because alpha is carrying 2 protons, 2 neutrons. So the charge is due to the number of the protons. So the number of the protons remains same. Magnitude of the electric force will be constant because F is equal to EQ. When E constant, same E is used, same charge, this force is constant. When force is constant, F is equal to ma. So acceleration is equal to F divided by m. Mass of the alpha constant, this force constant, so definitely the acceleration is constant. So we have to write here, alpha particle acceleration is constant because the force and mass constant. Why force constant? Because the same charge is traveling in the constant in the same electric field. So the magnitude of the electric force is constant. So the magnitude of the acceleration will be constant because same number of the charged particles carried by the alpha, mean 2 protons. So when charge same, electric field same, acceleration same. And the next, a nucleus X is an isotope. The mass of the nucleus X is greater than this Y. Both the nuclei are in the same uniform electric field. State and explain whether the magnitude of electric force acting on the nucleus. Yes, I have discussed already. Same force because F is equal to EQ. When force same, charge same, so same force is experienced by the particle. So it is actually the continuation of this part. So the acceleration is F divided by m. Electric force constant, mass constant, so acceleration constant. And why electric force constant? Because electric field constant, charge constant, so force constant. So actually, both parts are interlinked with each other. Okay, this is the paper.